Hi team, today I'm going to show you guys how to use the multimeter. For most of our cases and intents and purposes, we are going to be using diode mode, continuity mode, and volts DC mode. So, this isn't, right now it's off. This will be volts DC mode, and this is what we're going to use to measure how much voltage we're getting at a battery connector, or how much voltage we're getting at the charging AC from the battery connector as well. How much charge a battery actually does have to see if it's actually that the battery is not charged at all, and that's why the device is not turning on, and other things. If you're using a gaming console, for example, it can tell you if it's a power supply issue, and so forth. So that will be volts DC mode. This right here, we're going to use it quite frequently with iPhones and gaming consoles, as well as computers and MacBooks and all that good stuff. This will be continuity or diode mode. So diode mode would tell you if something's getting an appropriate reading, compare it to CXW, and then we know, yes, that number is correct, or no, there is a problem. And then continuity mode, it tells you if something is passing energy from one end to the other, and it'll make a beeping sound. So right now, let's do diode mode, which is the easiest one. So for diode mode, you want to make sure the battery is disconnected at all times, and that you are using red probe on ground and the black probe touching the cap, the filter, resistor, etc. So right now, because nothing is being touched, it's saying OL. OL means open line. Open line is pretty obvious. There's disconnection, or it's not being touched, end of story. So red probe is this one. This is going to touch anything that's ground or metal. So it could be a shield, the top of the Wi-Fi IC, Trinity AC, a screw post, a screw, anything that's metal, because that will be ground. And our black probe is actually going to be touching the end of the caps, the resistors, the filters, etc. So if you look at here under my scope, I have my red probe right here. We're going to put this right here on this particular IC, which is called Trinity. You're going to learn that later on. And this is basically right here, all this top section is ground. And we're going to use this big cap just because it's a really, really big cap. So we have red probe on ground, and here's our black probe. So if you can see, one under the cap is going to be 0, 0, 0. That means that section is ground. And then the other section is going to give you a reading. In this case, it's reading 441. That means this cap has a connection. One pad on ground, boom, 0. One leg on a line. It could be main, PP1, P8. It could be whatever line, right? And then that's 448. And then if you, for example, were to touch right here in the middle, because nothing's in the middle, it's going to read OL. OL is going to come in very, very, very handy because that means open line. We're going to learn up as we go, what 0, 0 means, OL means, and how we can use that to determine if there's a short or any other issue with the device. But that will be the gist of it. You want to use your multimeter and guide yourself with those. Now, everybody's favorite, because it's you don't got to get your eyes off the scope for this one, will be continuity mode. When you press both probes together, red and black, like so, you see how it makes a beeping sound? That beeping sound means there's continuity. That means whatever energy is passing from here to here, and boom, it's making a sound. So they're touching each other. Like, you can visually see they're touching each other, but for certain parts, like when we're running ground, or we're checking if there's a short on ground and you hear something do that beep, that means one end of the probe, which is ground, is touching the other end of the cap, which is ground. So back to our example right here, red probe on the shield or on whatever, and you see how if we touch that end of the cap that was 442, or that had the leg and whatever, it's not beeping, because that's a good cap. It's actually making contact, the proper contact, and it has a diode mode reading. But if we touch the other side, you see, it goes straight to ground. So ground is touching ground and it's telling you, hey, that's ground. It's going through, stop right there. So that's how continuity mode works. It makes your job easier in the sense that you don't have to take your eyes off the scope. So all you gotta do is just listen for that beep. But also there's tons of other tricks that you're gonna learn along the way to not let it fool you. Because there are times that it will beep and it's not necessarily that there's a short, but the voltage on that particular line is so low that your multimeter thinks it's short. Those are little tips and tricks we're going to learn along the way, but right now we're just focusing on getting you guys started with the basic of the concept. And as you guys progress, you're going to learn and become pros at determining what each sound and what each number determines. Now, the other thing we will be using at times would be voltage mode. With voltage mode, you can simply grab something like a battery, for example, to determine, hey, does this battery actually have charge, or does the charging IC is actually inputting and outputting the correct amount that it needs to be taking. So, for example, phones take 4.2 volts or anywhere from 3.8 to 4.2 to be more exact. Your average battery like this one, see, it says 3.79, so that's as much as it can handle. So when you measure a battery on volts DC mode, you want to make sure it's volts. And it'll say DC at the top right here. Sorry for the blurry image. And then you want to find your contacts. And for volts DC mode, you can actually leave the battery plugged, not the battery plugged in, but if you're measuring on a phone, you're actually going to do the thing where you connect the phone to the power cord, and that's going to supply energy, and then you measure the battery connector, and it tells you, hey, I am, receiving X amount of voltage. So in this case, we're going to use a battery just for trial's sake. Let's see. Making sure you guys can see. Okay. So we have our battery pros, right? And you see how right here, this is bouncing up and down, bouncing up and down. Okay, that's perfect. That's how it's supposed to be working because it's not touching anything. Once the probes touch the metal, the little gold points, you're supposed to get a steady number, whether it's 3.79 or 4 point something, but it will be a steady number for a few seconds. So let me show you guys what I mean. You see how I'm getting 3.5 steady? That means that this battery has 3.5 volts in it, which is not that great, but it would be enough to turn on a phone. You see how the number's steady? That's always what we want. If for some reason we touch it and the numbers bounce up and down like crazy, that typically means there's an issue with this battery, or there's not enough charge to get it to boot, or if you're measuring something like charging IC, that means that there's something wrong with that charging IC because it's not outputting the correct voltage the phone needs. So these are little tips and tricks I'm going to keep teaching you guys along the way. Don't forget. Don't forget to get your equipment from the list that you receive. That way your learning curve is not going to be as steep. And we're all in the same equipment and that can help you a lot quicker. If you did decide to get something else, go ahead and shoot me a message on Discord and we'll go ahead and take a look at that manual or what type of multimeter you have, and that way we can get you squared away and get you working properly with your own setup. Thank you so much for watching, you guys, and I will see you later. Have a good day.